We need information on how to navigate this changing world, and these speakers ground us in the effects and impacts of fire on organisms and systems. Our first speaker is Dr. Hal Mackey. He's worked in environmental projects for 54 years as a professor at the University of Pittsburgh in Johnstown and as a senior environmental scientist in South Carolina. We've been lucky enough to have him retired in Northern California, where he's been involved with Rob Schilsing, in understanding the natural history of 2 geophytes in Northern California and their responses to snow patterns, possible indicators of global warming, and fire. Please welcome Dr. Mackey.
Good morning. And it's a good morning because you're going to get to hear something probably pretty different and not, let's say it was never a planned experiment because the Dixie fire did it for us. Okay? So it's going to be somewhat different and hopefully enjoyable to you. As she said, we have worked on these 2 species of uniflora, Dicentra uniflora and pauciflora for the last 15 years. In part because it's ephemeral and it's only available at a particular site for 4 to 6 weeks for evaluation. So you get in and get your data, or you don't get it. Now, we have been able to characterize a number of features of it that were unknown previously, and some of these will, as we go through the talk, show you that they apply to its ability to survive during the fires or not survive. So we find that uniflora has about 60 to 70 seeds and 80 to 90% seed set. If you bury the seeds, if you're maybe an ant and you bury the seeds, you can get maybe 20 to 70% germination. Surface scatter, which you'll see some examples of, maybe 4 to 6% germination. The bubblets are 4 to 7 centimeters in the soil, and amazingly, we estimate that it may take 20 years to flower or more. Pauciflora reproduction is almost exclusively asexual by bubblets and rhizomes, and the bubblets and rhizomes are not quite as deep in the soil, and we have seen flowering in 10 years. So it does. So both of them have long maturation times. Now, the Dixie fire hit 3 of our study sites. Oh, geez. I don't know why it's doing that. Now I do. Okay. One of the sites is at approximately 1,700 meters in elevation, and we'll refer to it as the meadow site. The other one is at a higher elevation, 1,900 meters, and another site is close to meadow, and we refer to it as canopy. All of the sites had significant, intense burn around the margins. Fortunately, at meadow, the burn stopped close to the meadow and didn't damage the meadow very much. Summit intensely burned, both around and within the study site. We were lucky at canopy, where mostly it's pauciflora, and the 2-hectare area here received what we might call a control burn, and everything else around it was, well, it was totaled. So what we have are 3 different sites with studies that were ongoing And it's from these ongoing studies that we can say something about what happens to or how these plants responded to the Dixie fire. For example, in meadow, we have a bubblet plot that was planted in 2009. We have scattered seed plots, both at lower and upper meadow and at summit. We also have rhizome and bubblet sites that were planted at upper meadow, and we have transects that were established at 2 of the sites in 2009, and another transect that we established post-fire. So now let's look at some of the sites and some of the data from the sites. The first one is from Lower Meadow, and these are photos that were taken in October of 2021 after the fire. The fire stopped within 15 centimeters of the scattered seed plot at Lower Meadow. Upper Meadow had light duff, and it was lightly burned. Summit, toast. It's gone. The duff, everything just totally wiped out to the bare soil itself. So amazingly, 3 different levels of burn. So now let's look at some of the data from those scattered seed plots. If we go back and look at 2021, this is prior to the fire, we see anywhere from 50 to about 70 plants in each one of the plots at all 3 locations. Now let's fast forward to 2022, and in the non-burned site and the lightly burned site, about the same numbers of plants. Now let's go to the intensely burned site at Summit, and the numbers, well, let's see, 0 is a number. Okay? Curiously, we have also seen a decline in the lightly burned and unburned sites of about half in 2023 and in another half in 2024. And this may be related, we're not certain, it could be related to gopher activity. Now let's look at the plot that was planted, bubblets of pauciflora in 2009. This is a photo from 2010, and I don't know if you can see them or not, but the little tiny green plants here are the sprouts from those bubblets. If we go to May of 2021, you can see a lot more greenery and growth from those sprouts of the pauciflora. This shows that the site received a moderate burn with not all of the duff destroyed in the Dixie fire. This slide shows the plants as we have pegged them or posted them with skewers so that we can do repeated counts during that particular survey season. Or another way to look at the data is if we plot the number of leaves or plants that we saw versus time from 2010 to 2024, we see about 1 additional leaf per year. And in 2022, 23, and 24, no real decline. Apparently the plants survived through the fire, and it'll be interesting to follow this on for the next 5 years and see what we find. Now let's turn our attention to rhizome plots and bubblet plots that were planted of pauciflora in 2019. If we look at the numbers of plants that we see pre and post Dixie fire with respect to the rhizomes, we saw no real decline with the Dixie fire in this light to moderate burn. However, in June of 2022, and also it also in 2023 that I haven't shown, we had some heavy rains and erosion, and we have lost from outwash the plants in at this particular location. If we look at the bubblet plot that was planted next to the rhizome plot, we see the same thing prior to the Dixie fire, post-Dixie fire, good numbers. We have the erosion, and now we've lost everything at that particular site as well. Another unique thing that was available to us is that we set up in 2009 and 10 transects at Meadow and at Summit to look at density of plants of uniflora and flowers at that particular study location. We were able to go back and take our field notes and our photography from 2010 and recreate in 2022 those same transects. If you look very closely in the background, you can see the same trees, the same rock that was the start point for that transect, and the repeated types of things that are available for us here. To cut to the chase, if you look at the Summit site, the numbers drop to our repeated lost and gone. We did set up a new transect for pauciflora counts at Canopy in 2022, and we've seen that post-fire that we're getting about the same numbers of plants in our sampling plots over that time period. So it has survived that moderate to light burn. And if we look at the number of flowers in the pauciflora, we see actually we've gotten an increase in the number of flowers. Who knows? That may be due to release of nutrients or more sunlight availability. Let's see. Another thing that we've done over time, we're interested in what happens to the uniflora flowers and fruits over time. So we would go to a site like Summit, we would mark every available flower that we could find, and we would follow the fruit maturation of those flowers over time. Did they mature? Did they disperse their seeds? Were they eaten? And that provided us a database to look at from 2018, 19, 20, and 21 and 22 with respect to the fire. So we had good numbers of plants marked before the fire and in the springtime after the fire, with the erosion, and another complicating thing, hazardous tree removal because it's close to the road. I hate to say it, but 0 is a pretty persistent number. If we look at pauciflora fruits that we collected to characterize those particular fruits, we see that post-fire in that lightly, moderately burned area, we're still able to collect a reasonable number of fruits or count a reasonable number of fruits, flowers and fruits for characterization. Again, survival. Let's see. I've already mentioned some of these associated effects, and these photos are included to emphasize that. We can see erosion occurring in the heavy rains from June of 22. And when we go back and do our transects and our plots, we see that erosion continuing into 23. We have also, as I noted earlier, we're beginning to see more gopher tunnels and paths in our plots of both the planted bubblets and in our scattered seed plots. So we don't know if the gophers are responding to some change in habitat and that are allowing them to maybe migrate or move into our plots and our study sites. It's something that we'll try to figure out how to maybe quantify over the next couple of years. When we see losses, we have to be careful. We do know that we can have herbivory in our sites, and we always want to be careful and cautious that we are not saying the losses are due just totally to the fire or decreased numbers totally to the fire, because some of our past studies have shown that we can have 25 to 35% loss from herbivory. We had game cameras set up at Summit in 2021. Mule deer like to browse through our study sites. We've seen evidence of rabbit activity near and at our marked and staked plants at various locations. In 2018, we actually had the unique observation of being able to see a larva of the Paranecius coleus actually feeding on a fruit of uniflora. And this season, in 24, we saw for the first time longhorn grasshoppers at one of our other sites. So, in summary, a severely burned site at Summit. We can see a long view of it here, or another view of the transect. And when I say severe, I mean severe. If we have moderate to light burns, then probably both of these species can survive. If it's a severe burn, we're going to lose both of them. They just don't make it. Given the slow growth and germination times and maturation times for these species, one would expect that it could take perhaps hundreds of years for these two species to reoccupy a particular location. So maybe additional protection is needed in some of our environmental areas where we see less intense fires to preserve something for the future. I'd like to acknowledge that Rob Slissing of Chico is a major contributor and co-researcher on this project. A number of students, like Simone, who is working on her master's degree at Maryland, has helped in the past. We see Anna helping me get some pre-snow melt, get some snow depth measurements prior to our surveys. Laura Lamprey was a tremendous help in 2024 up there. My daughter Samantha, who is telling me it's probably time to quit, has always been my backup in case I did not check in at the end of the day. Because if I don't check in, she better send me some help, because I'm in trouble. If you want to know more about these two particular species, we published the biology of uniflora in Madronia in 2019, and we just finished a publication on pauciflora in September of 2024, and I hope that we have time for at least one question. No questions? Oh, okay. Yes.
Hi, Hal. It's Wolfie. It just so happens that the Lassen National Forest is developing a forest health project called the Upper Butte Creek Forest Health Project. NEPA, it definitely covers at least a couple of the sites that you've shown here, and that includes elements of preparing areas that didn't, doing fuels reduction in areas that didn't burn at super high severity, and also reforestation in some areas that did burn at high severity, what do you have any recommendations for protections or guidelines, as you mentioned, that based on the biology of these geophytes to help them persist into the future?
Those areas such as Scotch John Meadow, and there are a lot of meadows up near summits. I think that extra surveys are needed there as early in the spring as you can get them, and we've got to set aside areas like that so that some of that diversity is available for whatever plants may exist there in the future. A lot of them, some of them can just scatter all over the place, no real trouble. But some of them, like these geophytes, they may not have that. They may not have that ability. So identifying wetland and semi-wetland areas, protecting those, giving them extra protection, is probably it would be one of my recommendations. And I'm out of time. Okay? All right? So, thank you.